This August, you're going to look up and see stars falling out of the sky. Except they're not stars. They never were. The thing streaking over your head isn't burning up from some distant corner of space. And it's tiny. Most of them are no bigger than a grain of sand. You could hold hundreds of them in the palm of your hand. So, if a shooting star isn't a star, what is it? Where does it come from? And why does it show up, like clockwork, every single August? By the end of this, you'll never look at a wish upon a falling star the same way again. Because what's actually happening up there is far stranger and far faster than anyone tells you. Let's start with where these things come from. And the answer flips the whole picture around. That streak of light is a piece of a comet. Specifically, a comet named Swift-Tuttle. But here's the part that reframes everything. The comet isn't flying at you. You are flying into it. Earth is racing around the sun on the same loop year after year. And every August, our planet plows straight through a trail of dust and grit that this comet left behind, like driving through a cloud of gnats on the highway. You're not standing still, watching a shower fall. You're sitting on a planet moving 67,000 miles an hour, slamming into a debris field. So the shooting star was never falling toward you. You crashed into it. Now, about that comet. It is not small. Swift-Tuttle is a frozen ball of ice and rock about 16 miles wide. That's bigger than a mountain. It's actually larger than the object that wiped out the dinosaurs. And it swings through our part of the solar system only once every 133 years. The last time it came by was 1992, and it won't be back until 2126. But it doesn't need to be here. The dust it has scattered along its path over the centuries is still hanging in space, right where Earth's orbit crosses it. The comet is long gone, its crumbs stayed behind, and every August we drive right through them. Which leaves one very strange question. How does a speck of dust, the size of a sand grain, make a streak of light you can see from your backyard? The answer isn't the size, it's the speed. Forget a bullet is slow. These little specks hit our atmosphere at around 37 miles per second. Let that sink in. Not per hour. Per second. At that speed, you'd cross from New York to Los Angeles in under 2 minutes. All of that violent, staggering energy is packed into a single grain of sand. And when something moving that fast hits the air does not politely get out of the way. And this is where almost everyone gets the science wrong. You've probably been told the speck burns up from friction, like it's rubbing against the air the way you rub your hands together to warm them. That's not really it. Moving that fast, the grain slams into the air in front of it and crushes it, compressing that air so violently that it flares to thousands of degrees. The grain itself starts shredding apart, its atoms tearing off and smashing into air molecules, ripping them into a glowing, electrically charged gas called plasma. So look closely at what you're actually seeing. That bright streak is mostly glowing air. The rock is the trigger. The light is the sky itself, torn open and set aglow for half a second. And all of this happens shockingly high up, around 60 miles above your head. Higher than any airplane, higher than any storm, higher than almost anything else humans ever see in the sky. Almost none of these specks ever reach the ground. They vaporize completely, miles up, gone before they finish the sentence. The names even change along the way. Out in space, that grain is a meteoroid. The moment it's blazing across the sky, it's a meteor. And only if a chunk actually survives the fall and thuds into the dirt does it earn the name meteorite. Almost every Perseid you'll see never gets that far. It gives you half a second of light, and then it's simply gone. So how could anyone possibly know all this? That a half-second flash is a crumb from a specific comet? Astronomers traced it backward. Every one of these August meteors appears to shoot out from the same tiny point in the sky in the constellation Perseus. Follow those paths back, and the orbit lines up exactly with the dust trail of Swift-Tuttle. That's the fingerprint. And here's the beautiful part. People have been watching this exact shower for a very, very long time. The earliest known record of it shows up in Chinese astronomical writing from the year 36. Nearly 2,000 years ago, someone looked up at the same trail of comet dust you're about to see and wrote it down. And this particular year is one worth going outside for. The shower peaks on the night of August 12th into the 13th. And this time, that peak lands right on a new moon. No moonlight to wash the sky out. Just darkness and the meteors. Under a dark sky, you could see 50 to 100 of them an hour. You don't need a telescope. You don't need binoculars. In fact, your plain eyes are the best tool there is because they take in the whole sky at once. The only thing that really helps is getting away from city lights. Drive about 30 minutes out of town, and you can nearly double how many you see. So the next time a streak of light cuts across the night and you go to make a wish, you'll know the truth of what you're wishing on. It's a 2,000-year-old speck of dust shed by a mountain of ice, tearing through the air at 37 miles a second, setting the sky itself on fire, 60 miles above your head. A grain of sand, throwing the most spectacular goodbye it possibly can. And if a grain of sand can do all that, wait until you hear about the thing that makes up 95% of the entire universe that no one has ever seen. Not once. Subscribe and keep finding out what the sky is actually doing over your head.